Here is an explanation for the answer to final exam question number 95 in Electricity Demystified 2nd edition. Please refer to page 342 if you have the printed book. We're talking here about an electromagnetic signal in free space, and we're talking about its frequency versus its wavelength. Well, let's remember how that works. It's really quite simple. Frequency, generally abbreviated or symbolized as a lowercase italic f, and wavelength symbolized by a lowercase italic Greek letter lambda that looks like that. Okay? In free space, where the waves propagate at 3 times 10 to the 8th meters per second, or 300 million meters per second. Knowing that, and assuming that that remains constant, that's a pretty good assumption as long as we stay in free space, then the frequency in hertz equals 3 times 10 to the 8th. Actually, we can go to 2 significant digits. Let's do that. 3.00 times 10 to the 8th over the wavelength in meters. And contrary-wise, wavelength in meters equals 3.00 times 10 to the 8th divided by the frequency in hertz. Well, we don't actually need to make any calculations here. All we need to know is that the wavelength is proportional to 1 over the frequency, that is to say, inversely proportional to the frequency, and the frequency is inversely proportional to the wavelength. So this question is asking us, if we increase this wavelength by a factor of 49, what's going to happen to the frequency? Well, it's going to become 1/49th as great. 49 times the wavelength, 1/49th the frequency. That means the frequency will become 49 times lower. That's not any of the choices. That's not any of the choices here, so we have to conclude E, none of the above.